Scene script. Have you ever wondered what the world looks like on a microscopic level? Welcome to the fascinating world of nanotechnology, the science of the incredibly small. To give you a sense of scale, a nanometer is 1/1000th of a meter. Now, imagine a strand of human hair. You would need 80,000 nanometers to match its width. That's the realm we're exploring here. Nanotechnology, in essence, is the manipulation and control of matter at the atomic and molecular level. It's like having the power to rearrange Lego blocks. But in this case, the blocks are atoms and molecules. Why does this matter, you ask? Well, when we have the ability to control the building blocks of matter, we can create materials with properties that don't exist naturally. We can make them stronger, lighter, or more resistant to heat, for instance. We could even design tiny machines that perform tasks at a scale where conventional machines can't reach. The potential of nanotechnology is immense. It's like a new frontier waiting to be explored and conquered. From medicine to electronics, from energy production to environmental protection, nanotechnology has the potential to revolutionize every aspect of our lives. But it's not just about the future. Nanotechnology is already here, and it's already making a difference. The sunscreen you use, the scratch-resistant coating on your glasses, the stain-resistant fabric of your clothes. All these are examples of nanotechnology in action. However, like any powerful tool, nanotechnology also poses challenges. It raises questions about safety, ethics, and regulation. How do we ensure that these tiny particles don't harm us or our environment? How do we prevent them from being used for harmful purposes? These are questions that we, as a society, need to answer as we move forward with this exciting technology. In the realm of the incredibly small, nanotechnology reigns supreme. And as we delve deeper into this microcosm, we're learning to harness its power to shape a better, more sustainable future. Join us as we continue this journey into the fascinating world of nanotechnology. So, what exactly is nanotechnology? Well, let's break it down. The term nano comes from the Greek word nanos, meaning dwarf. In the scientific world, it's used to represent 1/1000th of a meter. That's about 1/80,000th the diameter of a human hair. Tiny, isn't it? Nanotechnology, then, is the science and engineering conducted at this nanoscale, about 1 to 100 nanometers. Here's a fun fact. A sheet of paper is approximately 100,000 nanometers thick. So, we're talking about a scale that's 1,000 times thinner than that. But why does this tiny scale matter? Well, when we get down to the nanoscale, the properties of materials can behave quite differently. They may become more reactive, stronger, or change their color. This is due to the laws of quantum physics that govern the behavior of particles at this scale. It's like we're dealing with a whole new set of rules. This new set of rules opens up a world of possibilities. With nanotechnology, we have the power to manipulate individual atoms and molecules, arranging them in ways to create new materials with unique properties. Imagine being able to design and build a material from the ground up, atom by atom. That's the power of nanotechnology. But it's not just about creating new materials. Nanotechnology also allows us to create incredibly small devices. Devices so small they could travel through our bloodstream, delivering medicine directly to diseased cells. Or tiny sensors capable of detecting harmful chemicals in the environment at levels we could never achieve before. So to sum it up, nanotechnology is all about understanding and harnessing the unique properties of particles at the nanoscale. It's about manipulating materials at an atomic level to create new materials, devices, and systems with unprecedented capabilities. Nanotechnology, in essence, is the science of the incredibly small. Now that we know what nanotechnology is, where do we see it in action? Let's begin with medicine. Nanotechnology is revolutionizing healthcare in ways we could only dream of a few decades ago. For instance, nanoparticles are being used to target cancer cells directly, allowing for more precise and less harmful treatments than traditional chemotherapy. These tiny warriors can also deliver drugs directly to specific cells, increasing the effectiveness of treatments while minimizing side effects. Moving on to electronics, nanotechnology plays a pivotal role. For instance, the microprocessors powering your smartphones and computers are the product of nanoscale transistors, which are getting smaller and more powerful with each passing year. Thanks to nanotechnology, we've been able to pack millions of these transistors into a space smaller than a postage stamp. Imagine that. In the field of energy, nanotechnology holds the key to creating more efficient and sustainable solutions. Solar panels, for example, are getting a nanotech upgrade, with nanoparticles improving their ability to absorb and convert sunlight into electricity. This could mean a future where our power is not only cleaner, but also more affordable. Lastly, let's touch on materials science. Nanotechnology is being used to create materials with extraordinary properties. Take carbon nanotubes, for example. Despite being 100 times stronger than steel, they're also 6 times lighter. They're being used to create everything from bulletproof vests to tennis rackets, and even components for space exploration. To sum it up, whether it's battling diseases, powering our gadgets, creating sustainable energy solutions, or developing materials with astonishing properties, nanotechnology is making its presence felt in a multitude of ways. It's a testament to human ingenuity, our ability to manipulate the world at the atomic level to create solutions that were once the stuff of science fiction. From curing diseases to powering our homes, nanotechnology is reshaping our world. With such a wide range of applications, what does the future hold for nanotechnology? As we dive further into the 21st century, the potential for nanotechnology continues to expand. Picture this: nanorobots so tiny they could swim through our bloodstream, diagnosing diseases and delivering targeted treatments directly to the cells that need them. This isn't just science fiction. Researchers around the globe are actively working on such technology. But it's not just medicine that stands to benefit. The world of materials science is also poised for a revolution. Imagine self-healing materials capable of repairing themselves when damaged, or ultralight, super strong materials that could transform everything from aircraft design to the clothes we wear. And let's not forget about energy. As we face the pressing need to move towards cleaner, more sustainable energy sources, nanotechnology could play a key role. Nanoscale materials have unique properties that make them incredibly efficient at converting sunlight into electricity, paving the way for next-generation solar panels. However, with all these exciting possibilities come challenges and ethical considerations. As with any new technology, we must carefully consider the potential impacts on society and the environment. For instance, what happens if nanorobots malfunction or get into the wrong hands? And how do we ensure that the benefits of nanotechnology are accessible to all, not just the privileged few? Furthermore, there are potential environmental implications. The production and disposal of nanomaterials could have unforeseen impacts on ecosystems. And while nanotechnology could help us fight climate change, it could also contribute to it if not managed responsibly. These are complex issues requiring thoughtful discussion and careful regulation. But one thing is clear: the potential of nanotechnology is enormous. It's a field that's only set to grow, and its applications are limited only by our imagination. So, as we look ahead, we see a future where nanotechnology is as commonplace as the smartphone, where it's a key part of solutions to some of our biggest challenges, from health to energy to materials science. The future of nanotechnology promises to be as small as it is vast. So, what have we learned today about nanotechnology? We've embarked on an intriguing journey, starting with the definition of nanotechnology, a field of science that manipulates matter on an atomic and molecular scale. We've learned that it's all about the tiny, the minuscule, the nano, a scale so small that it's 1/1,000,000th of a meter, a realm where the rules of classical physics give way to quantum mechanics. Then, we delved into the fascinating applications of nanotechnology. We explored how it's transforming industries across the board, from healthcare, where it's revolutionizing drug delivery and diagnostics, to electronics, where it's enabling the fabrication of smaller, faster, and more efficient devices. We also discussed its role in energy production, with solar cells and fuel cells becoming more efficient and cost-effective thanks to nanotech innovations. But we didn't stop there. We gazed into the future of nanotechnology, a future that promises even more astounding developments. We pondered the potential for nanobots, tiny robots that could perform intricate tasks within the human body. We imagined a world where materials self-assemble at the nanoscale, paving the way for extraordinary advances in material science. Yet, as we've discovered, nanotechnology isn't just about what's to come. It's already here, embedded in our everyday lives in ways we may not even realize. It's in the sunscreens we use, the clothes we wear, the electronics we rely on. It's making our lives better, one atom at a time. So, if there's one thing to take away from all this, it's that the world of nanotechnology is vast, complex, and incredibly exciting. It's a field that's poised to shape our future in countless ways, and it's a field worth diving deeper into. The journey we've started today is just the beginning. While we may not see it, nanotechnology is all around us, reshaping our world one atom at a time.